So, welcome to everyone. Today, we are going to talk about how to write a code, understanding about the threads and multi-threading concept in Java programming. First is that I gave a basic understanding about the thread. Then I will be spending, instead of teaching a theoretical knowledge of the thread, will give a demo of how your computer is working right now, how many threads are created in your computer, and how to understand deep dive into the threads. You might have studied in the college who has completed a computer science engineering. They might have talked about threads and processes. And who has not done the computer science engineering, they may not know about what is a thread, what is a process. Everyday life, you are working with threads and process. Whenever you touch the computer, whenever you open a computer, without knowingly, unknowingly, you are creating a lot of threads, a lot of processes every day. And we don't realize how it is working because we see with our visual eyes and try to open a Word document, try to open a PowerPoint document, you try to open a Chrome browser and do a lot of work. And behind the scene, a lot of threads and processor are being created automatically by your computer operating system. I will going to explain today how that is working and have a deep dive of a real-time example of process and thread before we talk about how to create a thread in Java programming. What is a thread? In Java, whenever you invoke a Java and class name, you're typing Java, running the class java.class name, and it directly goes to public static void main method. That is a main method that is called main thread. Means that whatever you write a line of code in the public static void main line number, it will be executing sequentially one after another. That is the main thread. It is executing it. So generally, thread will help you to make your program work efficiently, and also it helps you to work faster way. And these threads will execute at the same time. While you are doing one task, other threads are working other tasks parallel. We do human brain is also multi-threaded. So example of while you are driving a car, you do a lot of work while driving a car. So you drive the car and you're talking with the people and you're listening to the music, watching road and surroundings, and you talk with the people, you do a lot of work. So here, so how many threads you are creating? So your computer, your brain is your CPU. And you have ears. Your sensor is ear. Your eye is your sensor. Eye is looking at something, and you are taking the response back from the eye and goes to the brain and process it and decide what object you are looking at. Right? Ear. Someone are talking, and that voice will go into your ear, and you translate in your brain. You can respond back. That's how the ear is working. And mouth, you've been talking it, and by using hand you are driving the car, and using legs you are using the brakes, and you could able to smell while you are driving, and you can able to touch. Someone touches you, you understand the sense of it. So these all are the multi-threaded. While the car is still driving, while your car is driving, that is called main thread. So main focus is that you are driving a car, and parallelly all these are working for you, and you are doing a task multiple. Otherwise, if you don't do all these things, you will be just driving the car and you're not able to talk, and you are not able to smell anything, and you're not able to listen anything. If you do like this way, that is not a right way of developing any program. Like, it takes a lot of time to execute. So you need to do certain tasks parallelly and simultaneously so that your program will work more efficiently. Take an example of your you have a bank, and every month you get a bank statement to your home or in your account. There could be thousands of customers are in the bank, and they need to run a generating this bank statement by end of the month. Look at about it, how many bank statements it has to generate. If each bank statement to generate into PDF document takes 2 minutes or 1 minute, so how many customers are there? Maybe thousands of customers in multiplied by 1 minute, it is going to be like, it's going to run by 2 days or 1 days. 2 day or 1 day, 2 days or 1 days it takes, right? It's a lot of time. We don't want to run such a long period of a job, a computer program, right? So we need to do this in a more efficient manner. So that is the reason when you are writing a code, you need to think like how efficient I need to write, how which task can be run parallelly, which task can be run simultaneously. We need to think. Right now, whatever we have been teaching you are single-threaded programming, and we have not developed anything multi-threaded. So we need to think when you are writing a code, after writing a code with single-threaded, it takes 2 minutes to execute. The next step is you need to enhance the program. How can I run it? This program execution can complete in 2 seconds, 3 seconds. Which functions I can split into a multi-threaded. I can give another task to one thread so that it works parallelly. You need to think in this direction when you're writing a multi-threaded program. In the computer terminology, you might have heard a process and thread. So a lot of people will assume that both are same. Process is different from a thread. A process can create multiple threads. Within a process, we will have multiple threads. And a thread is one of the subtasks. Process has a lot of responsibilities to complete, and thread will take some unit of work and do that work. You can assign a thread for certain tasks, and you can create one more thread to do some tasks. If you take an example here, what I was talking about, human. So your data, what you are coming from UI is a one thread in your brain. The data is constantly reading. You are watching something constantly, and the data is coming to your brain and processing it and making you analyze what data it is. Similar way, you are listening always. The thread is constantly working for listening what is coming in your ear and decoding and letting you know that in your brain. Constantly it is working for you. Infinite loop. You see that the thread is working infinite loop in your brain. And mouth is constantly talking. These things are working, all are very simultaneously. Even you don't know that they are working like that. Even if you are sleeping and there is the threads are running in your brain, someone make a noise, you get up. Someone touches you in the middle of the night, you get awake, right? You understand that something is going wrong. So the way a human body has been structured, your computer system is called your brain. How these threads are running parallelly for your program. Similar way, we need to develop the code. Take an example, a real example, one more. You making a calls with using a cell phone. You take a phone and you make a WhatsApp call or you make another call. As soon as you make a call, you connect to your friend or your family member. How many WhatsApp calls are going every day in the world? There is a one company called WhatsApp. How many WhatsApp calls are happening in the world every day? A lot of video calls, lot of audio calls, lot of messages you are sharing, lot of videos you are sharing, chat messages, and only one WhatsApp company. Think about billions of calls are happening every day, and each call takes 1 minute to process. Do you think WhatsApp can do the work? WhatsApp will shut down. A company will shut down immediately. Whenever you call someone, and it may take a fraction of microseconds, not even a milliseconds, microseconds, to connect to a person who is in different country, very, very, very far away. How it works, whenever you call a phone from WhatsApp, you are in wireless. From there, internet connection should be there. Your service provider, the service provider, the call will go to that service provider. Before that, you are getting internet connection through the Wi-Fi. It should go to your cell tower. From the cell tower, it should go to your internet service provider. From there, you're calling a person called based on a phone number. That person is sitting somewhere in a different country. His phone also have an IP address. You need to detect the IP address of the phone and route the call to that person. He's in different country. Again, it has to ring. As soon as it rings, you need to get back the response saying that the ring is happening. He lifts, call will connect and talk. These many things are steps are happening inside whenever you touch a phone button. These things are happening very, 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 very microseconds to complete all these operations. It is very tough if you don't develop a multi-threaded program to accomplish this task. Not only multi-threaded, we need to do here in terms of the WhatsApp, we need to do the balance the load. They might have differently structured this architecture in different direction in the WhatsApp. I'm not going to the too complicated of the WhatsApp architecture, how they have developed. I am more concerned here to give an understanding about how the multi-threads are happening in the real world so that you can sense about it. Simple example, you see that you open a Word. When you open a Word document, you want to update your resume. When you're updating, you type your resume. As soon as typing, automatically edit happen. Alignment of the Word will does the editing. Alignment also, automatically alignments happen. Sorry. You're focusing on typing the words to develop your resume, and alignments of the word will does automatically alignment. When you are talking in PPT, when you are showing a presentation of the PPT, you see that what I am speaking are being displayed here. Automatically, my voice are converted into a text message. You are seeing it or not here currently. So how this is happening in the PowerPoint presentation? When I am presenting a PowerPoint presentation, and automatically what I am speaking is converted into an English words. I can change it to convert into any language. I can change it to convert into Hindi. I can change it to convert into Urdu. I can change it to convert into Telugu or Tamil. Any language I can show and demonstrate here. How this is happening while I am connected, while I am talking, and my computer is connected to internet, that is connected to the Azure framework, and it has a voice recognition software sitting in the cloud, and automatically it translating into the words and sending back to me on PPT and presenting on my PowerPoint presentation. All these things are happening in the behind the scene is multi-threaded program. If you see here, a Word is a process, PPT is a process, Excel is a process. Within that, you create as many as threads. Each thread is assigned to a process. Process knows when to create a thread, when to destroy that thread. The destruction of the thread is more important, which is decided by the process. Means that I created a thread means do some work. Your work is done, you die. I don't need you. That's how the process will decide. Again, I need to have another work. Again, I create a thread. It's like in a worker for the process. Do some work, delegating some work to the thread. So the thread do the work very fast and the process knows to focus on other threads. That's how a computer system has been designed in the behind the scenes. I will pause to get a sense of thread. I hope you have understand the what is threads and how the real world threads are being used. I can demonstrate more on this Windows computer how the threads are being used. Before I go on to the demonstration of how the process threads are organized in your Windows computer, and I will pause here for like 2 minutes. Any questions to ask?
Like Sham, does Red stores any data? Like once after completing the task,
It,
does that
it
data delete, like Red delete
you can
some
do
data?
anyone. It can do. It will do whatever you want. It all need a task. You do a task and give me thread as a worker. It's a worker. You give a task and tell them what should you do. It will do the work.
Okay.
I recommend everyone open the your task manager and just take a look at your task manager for some time. I also open my task manager in my computer. So just open your task manager in your computer and take a look at it. What is happening in the task manager? You might have seen this task manager, but not get into the more details of the task manager. So in this Windows computer, if you open a task manager, if you go into a little bit deeper into the task manager, you see that the processes, these are the processes are running. And each process, your computer has a 8 GB RAM, 8 GB RAM or 10 GB RAM or 16 GB RAM. And each process, it knows that how much CPU is utilizing. CPU means it is like your brain power of your computer. Like the way we have our brain, we can do certain works, then you say, I'm tired, I cannot work anymore. Like the way CPU also has a task power has been assigned. You see that right now, total, I have a 100% of CPU and I'm utilizing 30% of my CPU power. Means that still I have a lot of work. The computer can do the work. I can go up to 100%, 99%, 99 to 100%. If I go to 99 to 100%, my computer becomes slow. But I have opportunity to go up to 50 to 60% still. And how much RAM it is utilizing? It is utilizing RAM of the Chrome browser itself. It is utilizing RAM of 2462 megabytes it is using. If you open the Chrome, how many Chromes I have opened? These many Chrome windows I have opened. And 2462 is my total memory being utilized. And out of that, each Chrome window is utilized this much of memory. And the disk, how much disk space I am utilizing? Disk space means in order to do this work, it need to store some data temporarily. So it is using this much of disk space, not much actually. If you more disk space using means that your hard disk it is using it, the your process becomes slow and CPU increases automatically and the process becomes slow. And network, how much time I'm spending on the network connectivity, connecting to the internet. I'm not browsing anything, that's why my network is 0. It is like a human body, like I told about ear and I told about a eye and I told about the hand and the leg. So automatically it is giving a statuses how much time I'm spending. Something is working on the network to monitor how much disk space I'm using it, how much network connectivity I'm using it, how much disk space I'm using it, how much memory it is using it, how much CPU I'm using. Each process I'm getting the statistics here. And uh, if you go to the details section, so my processes are running and each one has and one unique ID has been created by the system. Means if I want to go and kill this process, if I type this number 35784, I can kill it programmatically, or manually also I can kill the process here. Whenever I kill the process, my PDF document will stops automatically. And it shows what is the status of each one. And you see that there is a suspended, some of them are running. Processor suspended. Some of them are running. The reason they are suspended is because maybe I'm not using actively. That is the reason they might have stopped it. These are not a threads. These are the process only. Do not confuse. Do not assume these are the threads. These are the process. This is how your computer system has been designed behind the scene. If taken a process, if any, go to the Chrome again, go to details again, and within the details, you see that each process again, yours, and the Chrome, we have a lot of windows I have opened it. Again, you are getting into the more details about this, and you can go to the properties, and you can see that exactly how many other details are about this one. So let's open one more Chrome browser. So right now I have how many Chromes? I have 21 browser windows I have open. So let me open one more Chrome browser. So I typed Yahoo. So my Chrome count has been increased again to 41. So when I open this Chrome browser, you see that I'm able to browse how fast it is coming web page. And within this web page, and my memory has been increased because I'm using a different one more Chrome browser. And if you see here, I'm getting a lot of images and I'm getting a lot of text. I'm getting a weather from different company altogether. And as I'm scrolling it, the news are keep on coming. The web page is mostly, if I go down, again, no new news are keep on coming. Again, if you go down, news are coming. How fast they are coming to me. I would recommend everyone open a Chrome browser in your computer. Open this Yahoo. Can you do it in your computer too? Then watch. I will show you some of the thing. You do the same thing in your computer also. So open a Chrome browser and type yahoo.com. And once you type the yahoo.com, I want you to go to here, the three dots, what you are seeing here. So open the three dots and go to more tools. So some problem in my computer, just wait a second. So if you go to the more tools, then go to the developer tools. So in the developer tools, go to the network. I hope you are doing all these things. Once you do that, refresh your by clicking this and watch these things pattern. Okay, what's happening? So I click refresh. You see that how the things are going very fast in the behind the scene. To load the page, how much data is being transferred back and forth between your browser to the server. I refresh one more time. You see that each one is doing certain tasks. Some of the things are being downloaded automatically for you, and behind the scene, what's happening in the web browser. So let's put this one. You see that some of them are you're getting images, some of them are getting the data from your server automatically. And all these things are happening very parallelly and telling exactly how much milliseconds it took your page to download all of these things. So each one has created a thread for you to load your page. You get a page in less than a second. Whenever you refresh the page, you're getting the page in less than a second. And the behind the scene, a processor is running for you. Your threads are created automatically, multiple threads are created, and data being loaded still. So it stopped now. It means it loaded completely your web page now. But for you, whenever refresh it, you are seeing a data very fast. Maybe not. You see, this image has taken some time to load. Again, I'm refreshing. See, this image is not coming, but you got the most of the web page already. It took some time to come this image. It means that each threads are working behind the scene of your Chrome browser, and it created multiple threads at the same time, and each thread is doing some of that task. So if you see that it stored flare.jpg, it bring the core.png, it has downloaded the sky.jpg. All the images are fetching by each individual person parallelly. And that is how you get this web page very quickly on the browser. And also it is telling to you how much time it took to execute each process. So if you take to load this JPEG to image, JPEG image, this is the image, JavaScript, it took 9 milliseconds. It took 9 milliseconds, not even a 1 second. Second has 1,000 milliseconds. It took 9 milliseconds to load. And this is working parallelly. Again, this is also working parallel, 11 milliseconds it took. Means that your threads are working parallelly, do certain work, certain tasks. The Java program, the code of written up by Chrome browser, behind the scene, they have spinning all these things in parallelly. So do not assume that we need to write a code for like this. The operating system also creates some of the processes, and your HTTP protocol, because the browser is running with a protocol called HTTP, that also creates the threads automatically. So combination of the browser who were developed and also the protocol, HTTP protocol who were developed, combination of all these programs, and also operating system is on the operating system, right? You're running on the Windows operating. Combination of all these programs working together created a multiple threads behind the scene. When I open up Chrome browser, I would see like in my task as a one process. Chrome browser is a one process. Within the Chrome browser, I am typing URL yahoo.com and trying to fetch this web page, and behind the scene, multiple threads are being created. without your user knowledge. That's what I want to say, that how the real world applications are working. That's how we need to start. When you are the developer, you need to think how I can create a multiple threads so that my program can work very efficient way and also simultaneous way it will work. That is my objective to explain this demo here to understand how the real things are working in the life. In this developer tool, you can still see a lot of things, because I'm not going to go into the all this. This is the web page. Whatever you are seeing this browser, this is all the HTML code page of this one, and you can see any errors are coming. And this is the complete source code. The complete source code of this web page, you are seeing that already downloaded from the server. This is the complete source code, JavaScript fold, CSS, HTML, all combination. You are seeing this code of this web page, whatever you're seeing. How the network is talks about the it talks about the connectivity between the web page to server, and how the performance and the memory allocation, application storage, how much data has stored. So that will gives more, like, giving a demo of the Chrome browser, but I'm more talking about this, how the threads are being utilized, created in your real life when you are working on the computer. And if you open the Word document, so this is one process. You create a one process of Word document. This is one process. I created a one word process, and I can keep typing the things. I can do something like, who. So instead of who, I put a, and you get this spelling automatic correction. Everything is happening. So these things are happening behind the scene is all through the multi-threaded programming. So this is the basic introduction of the Java threads, and also basic introduction of how a threads are created in a computer right now, what you are using in day to day. When you create a web page, when you access a web page, in the behind the scene, how many threads are being created? I want to express, that is the reason I have shown this demo to you, everyone. And tomorrow we can talk about more on to how to create a threads in Java program, how to understand the threads, and maybe run some practical example also, so that I want you people also can create a thread and demonstrate how it will work.